All right, in our next section here in chapter 10, we're going to look at 10.4. So we are going to pass on 10.2 and 10.3. We may go back and revisit later. Okay, but we're going to look at the surface area of prisms and cylinders. Okay, so we should know what prisms and cylinders are from our last lesson. So I think we should be able to kind of jump to this. Okay, now our warm-up for our prerequisite skills today, we're just going to find the perimeter and the area of each polygon that is requested. So the first one says we got a rectangle with a base of 14 centimeters and a height of 9 centimeters. All right, so let's maybe just draw a picture of this rectangle. So I'm just going to say this is, our rectangle. So this is 14 centimeters, and this is 9 centimeters. And I know that the perimeter is going to be equal to 2 times our base plus 2 times our height. And so our perimeter is going to be equal to 2 times 14 plus 2 times 9. Okay, and I'm just going to say now our perimeter will be equal to 28 plus 18. Okay, and 28 plus 18 is just going to give us 46, right? So our perimeter equals 46 centimeters. All right, now let's go ahead and take a look at our area, right? So our area of a rectangle is just going to be equal to base times height. So our area will be equal to 14 times 9. And so our area is going to be equal to 126 square centimeters. Okay, so easy enough on the first one there. Let's see if it gets any more complicated. Okay, this next one says it's a right triangle, and it has legs that are 9 centimeters and 12 centimeters. Okay, so let's go ahead and draw our right triangle here. Okay, I'm going to say this is our 12 centimeter leg and this is our 9 centimeter leg. Okay, so the first thing I want to know for a perimeter is I really want to know what this third side is. Right, and to know this third side, I have to use the Pythagorean theorem. So I'm going to say that 9 squared plus 12 squared equals c squared. So this will be 81 plus 144 equals c squared. Okay. I don't really feel like doing that in my head right now, so I'm going to run over to my calculator, and I get 225 equals c squared, right? So this is actually a Pythagorean triple, right? So if I take the square root of both sides, I'll find that this is going to be equal to 15, right? If you want to check in your calculator, obviously, please go ahead and do that. And we get that this is going to be 15, right? So therefore, the perimeter is going to be equal to 9 plus 12 plus 15. So our perimeter in this case will be 36. I better attach a label to it, 36 centimeters. Okay, and now we'll just go ahead and look at our area. Right, so area is really pretty easy. It's just the base times the height. Remember that the base and the height have to be perpendicular to each other. Right, so our area, is going to be 1/2, something I forgot, 1/2 times the base times the height. Right, so our area will be then equal to 1/2 times our base of 12 times our height of 9. So this will give us, half of 12 is 6. 6 times 9 is going to give us 54. So this will be 54 square centimeters. Okay, and now let's go ahead and delve into our very last problem here. It says we now have an equilateral triangle with a side length of 6 centimeters. So I'm just going to go ahead and draw our equilateral triangle. Okay, it has a side length of 6. Right, so our perimeter calculation is really pretty easy here, right? Our perimeter calculation is just going to be 6 plus 6 plus 6, or 6 times 3. So I'm just going to say 6 plus 6 plus 6. So our perimeter is going to be equal to 18. We are still in centimeters, so it's centimeters. Okay, now we have to take a look at our area, right? So our area might be slightly more challenging here. Okay, we want to know again, what is our area of this particular triangle? Right, so our area of this triangle is going to be equal to, we can think of this if we want to as a regular polygon, okay? But let's just do that. Yeah, let's think of this as a regular polygon. So our area is going to be equal to 1/2 multiplied by the apothem multiplied by the perimeter, okay? So I should know from last chapter that I can find the central angle here by taking 360 degrees and dividing that by 3, and it gives me 120 degrees. Okay, I then have to take that 120 and divide it by 2, and that gives me 60 degrees. So when I just go ahead and do this part, and I drop down this right here, I know that this angle measurement right here is going to be 60 degrees. Okay, I know that by 30, 60, 90 triangles, the opposite side of the 60 is going to be a radical 3 ratio. The side opposite of the 30 is going to be a 1 ratio, and the hypotenuse is going to be a 2 ratio, right? And so I know that this radical 3 ratio, I know that this side here that has to be half of 6, which in this case is going to be 3. Okay, and I want to maybe use these ratios to figure out, okay, what is our apothem? Okay, and so what I'm going to do here is I'm just going to write this down in ratio format. Maybe I'll write apothem next to this. Okay, so to figure out our apothem, I'm just going to do a radical 3 to 1 ratio is going to be equal to 3 to our apothem. Right, so our apothem here is, we're going to use the cross products property and say that radical 3 times our apothem will be equal to 3. And if I divide both sides by radical 3, I'll get our apothem is equal to 3 over radical 3. Okay, and then now I have to multiply both the top and the bottom by radical 3 to rationalize my denominator. So I'll get that our apothem is going to be equal to 3 rad 3 over 3. Okay, and so I end up getting, again, 3 times radical 3 over 3, which will just end up giving me radical 3, okay? And so our apothem is actually going to be equal to radical 3, okay? And so now, at this point, we can just plug in all of our information back into our formula here, right? So area equals 1/2 times our apothem, which is radical 3 times our perimeter, which is 18, okay? And I can just maybe say that our area is going to be equal to 9 radical 3 square centimeters. Okay, so again, we could also get a decimal approximation for that, I guess. So I can say what is 9 times radical 3? 9 times radical 3 is just going to give us about we'll call it 15.6, or 15.6 square centimeters. Okay. So again, I hope this is a helpful review for us. We can move on into some pretty cool problems in this section.